Hello, we're going to go through PTVN tables today. So the problem's up above here, and we are going to start out by reading this thing. So on a hot 305 Kelvin day, which is 9 degrees Fahrenheit, so that's our first temperature. So we want 305 K. You go to a hardware store and buy some spray paint to paint some chairs. The spray paint is initially at a pressure of 10.2 atm. When you get home, you decide to wait until night when it's cooler to paint the chairs, and you leave the cans in your car, which is sitting in the sun. And we all know that when we leave our cans, and if we leave something in the car in the summer, it's going to get really hot. So our temperature in the car becomes 344 K. And that actually makes the cans explode in your car, and that can happen. We want to know what the pressure of the can was right before it exploded. Now, an aerosol can, so a spray paint can, that is a non-flexible container, so volume is not changing. And we also didn't say anything about using this. We didn't use any of the can. We didn't use any of the paint. So the number of particles is also constant. So these two things are constant. Right there. So we're not doing anything with them. So we want to know what's going to happen to pressure. So we're going to draw two particle tables here, particle maps. We're going to keep volume the same because it's a constant. We're going to keep the number of particles the same because it's a constant. I'm just going to put 3 in there. And as temperature, from initial to final, temperature is increasing. So temperature is increasing. So if this is initial and this is final, we know that the arrows are going to get longer for this one. So the arrows are longer. So as the temperature increases, what's going to happen to the pressure? Well, the pressure is also going to increase because the particles are hitting the sides more often and they're hitting harder. So we want the pressure to increase. We want the pressure to increase. So we're going to take 10.2 atm, and we are going to say that as the pressure, or as the temperature is increasing, pressure is increasing. So we want this number to get bigger. So if we want this number to get bigger, that means that we need to have the higher number over the lower number. You're kind of just creating a ratio here. These two things aren't equal to each other like they were in dimensional analysis. You're just creating a ratio. You want the pressure to go up. So the only way the pressure can go up is if you multiply by the bigger number and divide by the smaller number. And when you do this, Kelvin cancels, and you get 11.5 atm, which is bigger. 10.2 atm versus 11.5, the pressure went up, which is what you want to find. Now, just to show you, let's say you picked the wrong thing. Let's say you did 305 Kelvin over 344 by accident. Kelvin still cancels. You're going to get 9.4 atm. Well, you should always look. 9.4 is less than 10.2. So that means that your pressure didn't go up, it went down. So this is not the right answer. It cannot be that because you know that pressure has to go up based on your particle diagram.